Alright guys, welcome to RC Mojo. Last week we took the little Rastar Land Rover out of its box, gave it a quick test and then took it apart. This week we'll install some hobby grade electronics, starting with the steering. I've designed and printed a couple of bits to do the conversion, and they'll hopefully be up on Thingiverse by the time this video goes live. If so, there will be a link in the description. If there isn't, just give me a poke in the comments. The setup is designed around the Tower Pro MG90S, the cheapest Metal Gear servo I could find with quick delivery on eBay. I paid under a £5 and it should be more than good enough for the task. Now I've already fitted a 4mm ball end to the third hole from the centre on the single-ended arm you get with the servo. The linkage bit I'm using comes from Sleck here in the UK, but Tamiya do 4mm cups and balls that'll be compatible too. The servo is a snug fit directly in the large part of the mount. To keep it in there, there's a cover plate that fits over the servo. The holes in the mount are threaded with an M3 tap, so we can just use a pair of M3x8 screws to clamp it all together. When the screws are bottomed out, the mount becomes very solid and the servo really won't be going anywhere. There's two mounting holes for the mount. They mount over the same post that the stock steering gearbox mounted to. I've also added a couple of wings that fill some of the gap around the steering link that slides back and forth. It'll help reduce the unwanted movement and hopefully get the truck going in a nice straight line. To add an attachment point for a ball end to the steering link, we've got this little part. The lump on the top is a tight fit in the elongated hole in the link, and the hole in the middle is tapped to M3. It'll probably be good enough just with an M3x6 nipped up to hold it together. But just in case, I've also put a small pilot hole in the adapter so you can use a small self-tapper if it's not quite good enough. In the hole near one end, we just need to thread in another 4mm ball end. We just need it bottomed out. There's no point in doing it up super tight, it's not going to be going anywhere. When designing the parts, I really wanted to try and do it so there's no cutting and grinding to do, but I just couldn't squeeze the parts in. Still, the mods are fairly minor. There's a plastic web that the ball end interferes with. You can still see it on the other side, and there's the rough plastic where I used the Dremel to cut away the plastic. It's not going to affect the strength enough to worry about, but it's not quite as clean as I'd like. That just leaves the linkage. It's made up from two Sleck or Tamiya 4mm cups with some M2 threaded rod between. Actually, it's just a screw with the head cut off, but it's all the same. The important dimension is the linkage needs to be 20mm from ball centre to ball centre. With the ball ends clipped in, we've got the steering module ready to fit. Now the geometry isn't ideal, but for what it's doing it's going to be more than good enough. Infinitely better than the stock system for sure. If we power it up with a servo tester, we can see it in action. When it's steering to the left, you can see the servo arm is more or less straight to the linkage at full steer. Not ideal, but it will never quite go that far when it's installed. Other parts of the steering limit the travel first. Steering the other way is just fine. It will probably mean to get the best from it, you'll need a transmitter with adjustable endpoints, as they're probably going to be a bit unbalanced. To fit the module, all we do is pop it in, lining the posts up with the holes, and we installed two of the self-tappers we removed in the last video. Nip them up and it's ready to go. If we power it up again with the servo tester, we can quickly check the steering moves from end to end without binding, but as long as you cut away the plastic mentioned earlier, it should be just fine. We can start rebuilding the rest of the front end now, and first we've got the wheels on their hubs. They just slot back into the holes in the chassis with the springs on the top. To make it easier, it's not a bad idea to pop something under the chassis so the hubs aren't being pushed out. The AA receiver pack that we used for the servo tester is just about the right size. Next the top plate goes back on with its 4 screws. Sometimes the outer post can be a bit reluctant to drop in, so you might need to push and pull things just a little bit to get it all to line up nicely. That just leaves the front bumper, and I didn't show its removal as it's just a couple of washer-head screws. Refitting though, it did need a bit of a trim to clear the servo. It's just made of a rubber, so a quick snip with some side cutters does the trick. With it all back together, other than the end of the servo sticking out, you never really know it's been modified. Pretty good, I think. If we flip the chassis over, we can give it a final test just to make sure that nothing's binding. You can see the little adapter going back and forth through the original steering trim hole too, which is fun. It's never going to have a massive steering lock without seriously hacking the chassis, but I think it should do the trick. We're not running through that awful clutch system anymore, so we should get the most from the steering lock that it does have. Next for the electronics, we've got another one of these little ESCs, and it's worth noting that the motor is going to take so little power, just about any brushed ESC will do the job just fine. And for the radio, we've got a typical FlySky 3-channel jobby. But first, I want to remove the last few bits from the body so I can get on and paint it ready for the next video. I've already taken the headlights off. The surrounds are just clipped in with the lenses sandwiched between the surround and the body. The clips just need a bit of force and they pop out. The windows are held in with 4 small self-tappers. One of them had been over-tightened at factory, so getting the screw out was a bit of a fiddle. Otherwise the window panels come out quite easily. The windscreen comes out with the surround and the wipers painted, so we won't have to try and paint them later. The rear light lenses are just a press fit, but they are very tight. I found a bit of help with a screwdriver to get them moving does the trick. Just watch out for overstressing the plastic. The grille is attached with 2 more clips and pushes out fairly easily. The 2 clips are different sizes, so when it goes back together you can't get them the wrong way round, which is quite neat. The vents on the top of the wings are a bit tricky to get out. The body has tabs that hold the clips out, so the small parts can't fall out. Great for stopping kids eating them, but it does mean you need to use a bit of force to get them out. The main thing is they're not glued, which is a major plus. For the back door, we'll need to remove the door card with its 4 screws and remove the latch mechanism. Now I tried to pry the spare wheel off, but it's very securely mounted. I tried a few things, but to no avail. You could remove the tyre and try and mask it, but it wouldn't be ideal. In the end, I heated the pin up with a soldering iron and pulled it through the black plastic part. Not ideal, but we should be able to rebuild it using a screw and a washer. The window is just clipped in, so that comes out with any fuss, and I was hoping it would, as there's an awful lot of detail on it. It's got the 3rd brake light and all the demist heating elements. Very nice. The side doors need their door cards removing too, and just like the rear, there's 4 small self-tapping screws. Then at the back, there's a funky little rubber widget that keeps the door closed. Now I do like that they didn't just use a hard plastic. There's a lot of nice little details on this model. The hinge comes out too with its 2 screws, and lastly there's the mirror, which is just a push fit. It's rubber with a barb on the end though, so it does need a good bit of a wiggle to come free. And lastly, because I missed it, there's another little vent on the side that needs to pop out too. So that lot's going off to be painted, and with any luck it will have hardened up nicely, ready for the next video. Right, let's get the chassis running. Now the receiver is fairly small, and there's loads of space at the front of the chassis. So when we get to it, we'll just stick it down with some servo tape between the posts on the front plate. I think the best spot for the ESC is going to be at the front of the battery box. It's going to be easy to route the battery lead, and I think when the interior's in, it's going to fit in the gearbox tunnel. And with any luck, there will be just enough of a gap for the wires to run to the gearbox. There's going to be a bit of soldering to do too, but it should be an easy fit. Before that though, if we test fit one of these 800 mAh 2S LiPos, we can see it's not quite going to fit under the lid. And of course there's all those battery springs, which we really don't need anymore. Another neat little thing with this model then, the battery box is a separate part held in with 2 screws and a couple of clips. All we do is take the screws out, and with a bit of manhandling remove the battery box. It would be a lot easier if we took the front end apart again, but you can just about get it out without. Next we can remove the switch with its 2 screws. You don't have to, but we're going to be making a lot of dust with the Dremel, and the switch isn't sealed, so it's safer just to remove it. We'll also need to straighten all the little tabs out on the metal plates. Once the plastic's cut away, all the metal bits should just drop out. And here we are then. After a bit of dremeling, we've got a nice empty box. Now I did start designing one for 3D printing to save hacking the stock part, but this will do the job just fine for now. We need to clip it back in and refit the 2 screws, then refit the switch with its 2 screws. Motor next, and we've got a choke and some very fine wire. The choke, the round bit, is there to suppress electrical noise, probably due to interfering with the basic 40 MHz radio that the model comes with. Also, those long thin wires are going to have quite a bit of resistance, which will be part of the reason the model seems quite sluggish. probably a good thing from the point of view as a toy. It means banging it forward and reverse won't do any damage. To get to the motor terminals, we need to free up the gearbox. Now, we won't be able to remove it completely without removing the press-fit wheels, but if we remove the top spring mounts, we will be able to get a fairly clear shot with the soldering iron. The top mounts are held in with 2 screws each, so we just pop them out and Bob's your uncle. But do keep an eye on the springs though. They are very long, which is probably why the suspension's so stiff, and they do push the top mounts quite hard, so there's a good chance that they're going to ping off. Now, they've really wrapped the thin wire tightly around the motor terminals before they soldered them on, so I'm just going to cut them off. The choke is glued onto the tab, so to remove it we're just going to pry it free. We're not worried about damaging it, so we can employ a little bit of excessive force to do the job. Next, we need to add about 1.5 inches to the motor wires on the ESC. We want the wires with the BET connector on the end with the sockets. I'm just going to chop the connector off, splice in a bit of extra wire, heat shrink over the joints, and solder the wires to the motor terminals. Now, before we reassemble, we should do a quick check just to make sure everything works and the motor spins. All we need to do is connect up the ESC and steering servo to the receiver, steering to channel 1 and the ESC to channel 2, connect a battery to the ESC, turn on the transmitter, then the ESC, and see if it all works. Well, that looks good enough. It's a bit wobbly at the moment, of course, but it is running. The top spring mounts can go back on now. Now, it would be nice to find some softer springs to go in there, and the front as well. I think if we could get 5 or 10 millimeters of articulation with the chassis fully loaded, it would be far nicer when running. It might even lean a bit when cornering. Next, we'll swap the small switch on the ESC for the one on the chassis. It's just an on-off switch, so all we need to do is chop the switch off the ESC, strip and tin the ends, solder them to the switch, and insulate with some heat shrink. Now, to try and get as much clearance as possible, we'll make sure the heat shrink makes the wire hug the battery box. Once the heat shrink cools, it should more or less hold its position. There's always something that gets missed on these little builds. We're going to need a hole that fits the BET connector for the battery lead. We want it right up at one corner of the battery box towards the front, so the battery can go as far back as possible, and we've got plenty of space for the battery wires. So after a quick buzz with the Dremel, we can move on. It would have been a bit easier to do when we had the battery box out, but never mind, it'll do the job. Before we stick the electronics down to the chassis, we need to make sure the surfaces are all nice and clean. A bit of IPA does the trick, and if you're lazy, alcohol swabs do the trick just fine. A quick wipe around on all the surfaces and you're good to go. Now we just use some servo tape to stick it all down, making sure all the bits will fit when the body goes back in, or at least be as sure as you can be. The servo wires are going to need a bit of a tidy up, which I've done off camera. A little bit of folding and a couple of zip ties, and it all looks nice and neat. For the antenna, I've just stuck some antenna tube to the inside of the sill with a bit more servo tape. It's really not an ideal position for it. It's way too low and it's going to be right next to the battery. But it's only really going to be used indoors, so having a limited range shouldn't really matter much, if at all. Well, we can pop the battery back in now and do a quick bench run. Well, it still sounds a bit weak, but it's a lot better than it was stock, and you can actually drive it slowly. It would be nice if we could change the gear ratio, but I think that's a bit beyond the scope of an easy to do set of mods. It's likely we'd probably need to replace the entire gearbox. Next time we'll have a look at the body and refit it, and possibly install some lights if time permits. Anyway, that's it for now. So as always, thanks for watching. Like if you liked, subscribe if you haven't, and leave a comment if there's something on your mind. Bye guys!